Okay, so this is going to be about section 1.2. Section 1.2 kind of takes us from categorical data that we talked about yesterday into looking more at quantitative data, which of course is numbers, numbers that kind of make sense when we do calculations in math with it, like mean, median, that kind of thing. So the homework is up here. You can sort of see, and I'll post this on Schoology as well, but just some problems to keep up with what's going on, what we're doing in class today. For tomorrow, I would like you just to kind of read through this section in the book, section 1, 2. A lot of it you'll find familiar, but there are some intricacies of things, that I would like you to be aware of and just kind of have a chance to read about. So if you could read through section 1, 2, there is also a reading guide. There's a section 1.2 in the reading guide. If you wanted to work on that, you could, just to kind of keep up with things. We are going to have a test, or rather a kind of a big quiz next Friday over Chapter 1. Chapter 1 is a little bit of a smaller and shorter chapter. We will have a test over Chapter 1 and Chapter 2 in a couple of weeks, but we're just going to have kind of a small test, big quiz over Chapter 1 next Friday. And because of that, because of the kind of the quick turnaround there, I'm going to have the reading guides due on Friday, on the day of the quiz. So that's just kind of a little bit of a look ahead into next week even. But make sure you bring your calculators with you tomorrow. We're going to be doing a data activity. I have a worksheet for you, or a packet rather, that has some data, and just to kind of familiarize or refamiliarize yourselves with the calculator and some of the functions that the calculator has built into it to help us with data analysis and whatnot. Okay, so hopefully my guest teacher substitute has passed out the note set. Again, this is on section 1.2, graphical displays for quantitative data. And so we're just going to kind of take a look at 3 different ways to look at quantitative data in this particular section. And again, like we talked about yesterday, we really just kind of got into bar graphs and pie charts and talked real briefly about why you would choose one over the other. That's kind of the goal for today, is to just kind of look at some of the big data displays and to kind of get a sense of when we might use one over the other. So we'll start with a histogram. I'm just going to write a couple things down here. So histogram, first of all, the data is broken into bins. Sometimes those bins, depending on the book that we're using or looking at, are called classes. The horizontal axis is actually a number line. Okay, and that's a distinction between a histogram, which could kind of look like a bar graph, but again, this is for quantitative data rather than categorical. We use a bar graph for categorical. This one, the horizontal axis, is not a category, but rather is a number line, and how many things fit into each of those bins. And then, generally speaking, we want to have the columns having equal width. And ideally, maybe no spaces in between either. If that's possible. And sometimes, just because the data set, there might just exist some natural gaps in the data. But we want to kind of think about not having spaces in between. The columns have equal width, so we can make comparisons between the bins or the classes. Your calculator can do this, and you may have seen this already in previous classes, but this is a data set from, I think it's the percentage of foreign-born citizens in each state. And so I think there are 50 data points here. It might be Puerto Rico or something else in there as well. But I think there are 50 numbers in here. And again, so this is what a basic histogram would actually look like. And so you can sort of see from this that the horizontal axis is actually a number line. Notice that it goes from 0 up to 28. The bin width, or the class width in this case, is 4. And so if you click on one of these, you can sort of see that the range of values or the interval of values that it has there is from 0 to 4, and there are 16 points in there. Again, what that would mean is that there are 16 states that have somewhere between 0 to 4% of their population are actually foreign-born. And again, here from 4 to 8%, there would be, looks like maybe about 13, I guess, 13 different states that have that. Between 4 to 8% foreign-born citizens, and so you can kind of use this and see. I guess the one thing to kind of note here is when it shows you the intervals, notice that 4 is actually included. There's a bracket there, and 8 is not included. So if we were to have a data point that was exactly 8 points, that would actually go into the next. You round that up to the next bin. And so that's common for histograms, that if something falls in between two, you always put it in the one that's above. And it has that kind of traditional interval notation with parentheses and brackets to kind of reinforce that. But you can always click on these, and once you get some data in the calculator, it's actually it's pretty cool. There's a lot of stuff you can do just like by clicking on things on the graph, and we'll see that over the next couple of days. So to get back to the note set here. So there are some pros and cons to a histogram. Why you might use this. Pros is that it's pretty easy to understand. It's pretty straightforward. It does look like a bar graph, and so I think that's a pretty commonly understood way of representing things. And it's really good for large sets of data. Just to show some quick trends. The cons, or things that are maybe not necessarily really good about a histogram, is you actually lose the original data. And we'll be able to contrast that with what we talk about here in a little bit. The data is actually lost. We just have, the only thing we can really tell if we go back to this, to this guy, the only thing we can really tell is that there are 13 points between 4 and 8. We don't necessarily know what those numbers are unless we have the accompanying data set. So we do actually lose the data for simplicity of the graph. And then, something else here is that the variable bin widths can actually alter the look of the data. As we'll see in a little bit, part of what we want to do with these graphical displays is to actually get a sense of what the data look like and what their kind of trends are. So if we go into here real quick, we go back to the calculator. There are a couple different ways that we can mess around with this. One is we can actually just kind of grab on here and change those bin widths. And sometimes depending on what the data set, let's click out of there, what the data set actually looks like, it can sort of change the way that the data are distributed just based on how the bins actually change like this. Now, one other thing that's important to note is you can do this by hand also, not by hand, but rather through the menus. If you go into plot properties, histogram properties, bin settings, and then equal bin width, you can actually change the width of the bins and where it starts and all that. So if I want to go back to that original one, I think we had a bin width of 4. We'll start it at 0. You kind of see this is back to where we started from. And so you can change the way that looks a couple different ways, either by just clicking and dragging around. I think it's a wee bit harder on the calculator, like on the handheld calculator here. Obviously for me it's really easy. But you can also go through the menus to change those as well. And that will become important for some things we do down the road. All right, so that's pretty much what we need to talk about where histograms are concerned. Another one to talk about is dot plots, and we've already done that with the smelling Parkinson's disease. We made a dot plot. We've made a dot plot the other day for the heartbeats. We have one up on the wall that's a proportion of white beads. So this is a pretty straightforward one. Now the calculator will actually do this as well. we can change the plot type to a dot plot. And again, tomorrow you'll have a chance to kind of look through some of this, have a packet to kind of introduce some of these ideas. But we can do a dot plot here, and just notice that it just changes it to a dot plot. And so that's pretty straightforward, and we've worked with that enough. We already have seen what a dot plot looks like and kind of how it works. Let's just kind of look at the pros and cons here. So we'll write a couple other things down here. So we have dot plots as well. And so we kind of know what a dot plot looks like, let's just talk about the pros of the dot plot. It's quick and easy for small data sets. That's why we started with that one, just with some class activities. It's really easy to understand also. And in this case, we actually get to keep the original data. Which is nice in some cases. Again, if it's a small data set, just kind of go back to here, and you can actually click on these guys, and it will show you what the values actually are. And also because of where it's located on the graph, you can have a pretty good estimate of what it is. Also, these these have a little bit of overlap, and so the dots don't fit in there perfectly sometimes. But at least you can get a ballpark figure for what the actual data values are, and the histogram doesn't allow us to do that. So that's definitely an advantage to the dot plot. However, it also is a reason that there is a con, or a couple cons rather, for the dot plot. It's really tedious. That's really the only one. It would be really tedious and actually kind of unusable for large data sets. If you think about, if I did that heart rate experiment the other day with 1,000 people, let's say, making 1,000 dots, trying to plot that would kind of end up being a little bit of a train wreck. So generally speaking, we use dot plots for just kind of quick and easy, for small data sets. All right, so on the next slide we have stem and leaf plot. Stem and leaf plot was a little bit different, a little bit harder to make one, to kind of understand it. So we'll just kind of talk through one real quick. So this data set, this is from a UNICEF report from 2005. So this included the accompanying data on the percentage of primary school-age children who were enrolled in school for 19 countries in Northern Africa and 23 countries in Central Africa. And so, this data point here means that there was one country in Northern Africa that had 54.6% of its primary or elementary school-age children were actually going to school. And so, UNICEF, of course, is a United Nations organization that focuses on, children's needs in emergency situations or kids that are in crisis. So one of the questions that they might ask about the data is, are those percentages of children enrolled in school roughly the same for countries in Northern and Central Africa, or are there differences? And if there are huge differences, then what might be some policies or some funding or some support structures, try to make those things a little bit more equal, or to bring some countries up a little bit more to where the other ones are. So we're just going to create a stem and leaf plot to investigate that question. Essentially, how do those two regions in Africa, between the Northern Africans and Southern African countries, how do those actually compare to each other? Okay, so the basic idea here is we're actually going to eventually make a back-to-back stem plot, but we're going to start with the northern countries. And so when we look at the northern countries, what we want to kind of look for here to get started is the smallest number, which I think is this guy here, and the biggest number, which is 90-something. Where are we? 98.8, I think. Yeah. Okay, so those would be our biggest and smallest numbers, and I know you've seen these before. So what we want to do with that is we're going to put this right smack in the middle here. So I'd like you to do the same here. So this is like literally like a stem and a leaf. That's where the name comes from. So we're going to make the stem of this. And what we're going to do is we're going to put the first digit of those numbers. So this top one would be like to represent that 34 number that we had. So that's the stem of our plot. And then over here, we're just going to put northern countries. Okay, and then essentially what we're going to do is we're going to go back up here to the numbers. And so, one of the drawbacks of a stem plot, it takes a little bit longer sometimes. Sometimes we have to make some concessions with how much of the number we actually show. Now this one, the data set has a tenths of a percent, and so we're probably just going to knock that off and leave that sort of behind. So the idea would be that the leaf part of it, the things that are going to go out to the right in this case, we're only going to have space to put one extra digit there. Okay, so sometimes that stem in the middle could actually be 2 or 3 digits, the stem part, but the leaf is always just a single digit. And so just because of the spread of the data in this case, what we're going to want to do is probably just round each of the numbers from up above. Okay, which means that if I'm trying to represent this 34 number, I'm going to actually put that. And in addition, once I kind of make that decision about how to do these, I also have to make a key because different stem plots, different sets of numbers could mean different things. This could be 34,000, it could be 340, it could be 0.0034. It's just that 3 and the 4 are the important numbers there. And so we need to say how we're actually going to read that. So down with stem plots, you'll always see a key at the bottom, 3, and then line 4 in this case, since we're plotting that number 34. And it can really be any of the numbers. I just chose that one because that's where we're starting. So that equals 92%, or 92, sorry. Look at the wrong example. 34%. Okay, so just some sense of how to read that so that we can differentiate 34% from, 340 or 3,400, something like that. Okay, so after we get that key made, we kind of have a structure for it here, then we're just going to go ahead and start plotting these things. And what I would suggest is to just kind of cross them out as you go. The next one here would be this guy, 48.9. We're just going to call that 49. So that'll go here. And you can just sort of keep going here. And again, I would suggest that as you plot these things, that you simply cross them out. This would be a 55. And that's going to be, I'm going to run out of space here to be able to go back and forth here, but any 60s here. We're going to call this one 60, the 59.6. Round that one accordingly. All right, now we're just going to almost have to look off my paper here. So we're just going to kind of keep going with that. Notice that there is one that we can round to 78. There are several in the 84 range up there. And so here's where we want to put the ones that are in the 80s numerically from smallest to biggest. So there is one that says 83.9 up at the top, and we can just kind of go gather those up here too. So this guy is an 84. This one is an 89. This one, go ahead. What am I going to do with that one? Let's round that to 9 too, I guess. 89. Another one. Yeah, 87. Okay, so since we have 4 that are in the 80s, we're just going to put them numerically 4799. Now what we want to do with this is just put a little bit of space in between them so that we can actually tell the differences between the numbers. Just a little bit of space, and we want to kind of keep them nice and aligned vertically also. We'll go ahead and do the 90s as well. Again, we're going to put those in order. And the idea here is to make sure that these are nice and lined up. Okay, that will allow us to compare between the categories a little bit more easily. Okay, so let's start making a pro and con list, and then we'll come back to the Central African countries too. So there are pros to this approach. Pros would be that we get to keep all the data, and that was a drawback with the histogram. Now, however, that does present an issue that it's not practical for large data sets. Again, we see this, there's this trade-off between keeping the original data and having an efficient way to show it on a graph, and those two things usually can't coexist. So that's not practical for large data sets. And we may need to round the data in some way. So even though we're keeping the data, sometimes we have to round it or truncate it or something. We can't actually see all the numbers sometimes, like in this case. One of the other benefits of this is we can actually use it for comparisons. A pro of this is it's really good for comparisons if I have small data sets. And that's kind of the second part of what we need to talk about with the stem plot, is this idea of doing a back-to-back stem plot. Now, so what we'll want to do here is we're going to put one over here for Central. And what we like to do for the Central African countries, what we like to do is to just put those back to back so that we can actually compare the numbers a little bit more efficiently. And so let's go to the 30s here. So if we go up into the Central African data, we have in the 30s, we have those two, we have this one, this guy. That's it. So we're going to just kind of round these. So we have 39 here. We've got 35. Another 35 here. And then this one looks like it's going to round to 36. So those are numbers that we want to actually show here. And so just like we did these numerically from smallest to biggest, these guys here, we're going to do that same thing here, except it's going to go kind of backwards through the numbers. It's actually going to go from right to left in this case. And what that means is we're just going to write them like this. So this would be the number, 35 rather, another 35, a 36, 36, and a 39. So the numbers always get bigger from the center out. And so that's a little bit confusing maybe. So go ahead and take a minute, go ahead and press pause if you want to, and see if you can come up with this on your own. And then I'll put the answers up here in just a second. So go ahead and complete that side. That's what I would have you do if I were actually in class. Go ahead and work on that, and then we'll come back together here in a second. Okay, so this one kind of ends up looking like this. And so the purpose of this, again, is it gives us good back-to-back comparisons, which we'll come back to in just a second. But we want to first, before we start comparing them a little bit more formally, we want to talk about how do we actually do a comparison? What are the important aspects to kind of talk about? And so one of the things that we'll talk about, we will see this a lot this year, is this idea of describing distributions, just to get a sense of a few sentences about what the thing actually looks like. How do they compare if we're doing a comparison like this? And so if you flip to the next slide, the back of yours probably. So we're just going to describe a distribution, and I have kind of an edgy, slightly edgy way to talk about this. It's an acronym, just so we don't forget some of the things. So the one that I use is CUS and BS, and so we'll just write that over to the side here. CUS and BS. Okay, so the main features that we always want to describe or talk about when we're looking at distributions of data, first of all, would be the center of the distribution. And generally for that, we would use a mean or a median. Okay, we'll talk about how to find those and obviously things you've done before in previous classes, but we'll talk about that more a little bit tomorrow with the packet you're going to be working on. We want to talk about any unusual features. And that would be things like outliers, any notable gaps in the data, any clusters or groupings in the data, that kind of thing. We want to talk about the shape of the distribution. And we also want to talk about the spread. What kind of a range or what kind of a measure of spread can we talk about? And then the last thing is not the specific, or not the individual things, the four things we want to talk about. We also want to be specific if we can. And so that's very different from the way that we usually think of BS, and we're actually trying to be specific in this case. And so what that basically means is that we want to give numbers if possible. Okay, so if we're talking about the center of the distribution, let's calculate its mean, or let's give its median, that kind of thing. Okay, so I want to talk a little bit specifically about the shape. There are some main shapes that you'll see, and things that we want to kind of talk about here. So if I have a histogram, let's say, that kind of looks like this, and again, this won't be perfect, but if I have something that kind of looks like this, the idea with describing distributions is that, if you were to throw, I heard somebody, another stats teacher way back in the day sort of write about this, that if you were to throw a tablecloth over top of the data, like what would the basic shape of it be? So we're not so concerned about this thing right here, that it's quite a bit lower than the other ones. If you look at the overall thing, if you were to throw a tablecloth over this thing, what would the shape of that be? And so this would be what we call a uniform distribution. Again, this idea that they all kind of top out around the same area, we call that a uniform distribution. We have another one that if our histogram, let's say, were to look like this, we kind of see that if we were to put that tablecloth over the top, it would probably just sort of do something like that. We call this a mound-shaped, M-O-U-N-D, mound-shaped distribution. If we were to have a distribution that looked like this, or a histogram that kind of did this, and we were to throw our tablecloth over top of that, it would look like this, kind of has a tail off to this right-hand side. We call that a right skewed distribution. Okay, that tail for the tablecloth kind of comes out here to the right-hand side. We say that that's skewed right, or it's pulled to the right a little bit. And then we have the opposite of that. If we have something, not doing a very good job of drawing these, but if we had something that looks like this, we would put our tablecloth over top of it. What would that look like? Again, we have sort of a tail over on this side. We would call that left skewed. Okay. So we also have this last one, which we don't see that much. Something maybe that would look like this. This actually happens quite a bit in real data sets. Throw our tablecloth over top of it like this. This is what we call a bimodal. Bi meaning two, of course, and mode meaning that it's the most occurring point, right? There are two peaks of that curve. So anything has that. And of course, these other ones are we call unimodal, except for this guy. But there's a unimodal here because it has one peak, as do the skewed distributions. We can also talk about, things being symmetric. Some of them are symmetric. We want to be more specific about what type of symmetry is actually there, whether it's a bimodal or whether it's uniform, whether it's unimodal. Um, those are all, or mound shape rather, those are all symmetric. And so if I look at these, the ones that are symmetric would be, I guess, A, B, and E has some symmetry here also, right? So A, B, and E would be all symmetric. Okay, so that's the way we describe the shapes of distributions. We want to use one of those words to kind of describe that. So let's go back then to the African countries data and just kind of talk a little bit about how we might discuss that. So the idea here is that we wanted to actually make comparisons in the data set. And so I think about 3 or 4 years ago, one of the questions that I graded on the AP exam was about making comparisons between distributions. This is something that comes up a lot in a lot of different kinds of problems that we're going to do. And what I found was, as I was reading literally hundreds and hundreds of these things, was that the ones that were really good and just read very well, scored very well, started off with an overall statement. Before we got into the cuss and BS thing, just there was an overall statement of, like, what's your first impression of the data set? And then beyond that, it would go into, okay, well, this is the center of each of them, and this is the, the spread, and so on and so forth. And so I think just looking at these two sets of data, to me, it seems like the northern African countries have a much higher percentage of children that are enrolled in school. I think that's a pretty obvious first impression for these things. So we're going to start our statement off with that. So I would say, let's see here. So we're going to compare the distributions. So overall, the northern African countries in here, we're going to put in NA because we're going to use Northern African quite a bit as we write here. So those Northern African countries have a higher percentage of children enrolled in school, primary school. Okay, now we start going through the cuss and BS acronym. Center, spread, shape, that kind of thing. The next thing, you can kind of do these in any order. It just think about how it's going to flow as kind of a story. You're really kind of telling a story about the data and how these two regions compare. To me, I think I look at the spread of these things and I see, well, both of them started about 34, 35 in the mid 30s. They both top out at 99, so they actually have the same range of values, but what's going on in the middle is very different. So I might start with the spread and say something like this. Although both distributions both distributions range from the mid 30s to almost 100. They are quite different. Quite different. In other ways. So that's our spread. Let's see here. So maybe the median of these things, and again we'll talk a little bit more about median, but you probably remember this from back in the day. Northern African countries have, I think there are 19 of those. Yeah, there are 19 of the Northern African countries, and so that means that our median would be the 10th point. And you can like cross these out if you want. Probably did that back in the day. But where we can be specific with things, we want to kind of do that. And so that's this guy right here. So the median of the northern African countries is 92. We can do the same thing with Central Africa. Central Africa has 23 countries, which means the median is going to be the 12th point. So if we start counting these, it's going to be this guy right here, which is 62. So that's a lot different story, right? Even though the ranges are essentially the same thing, the centers of those distributions are quite different. Okay, so let's go back to here and discuss that a little bit. So something to the effect of, that maybe the median, this is where we be specific, right? And we were specific with the other one too, talking about the range and the top and bottom values there. So the median of the Northern African data is about 92%. And since we're making a comparison here between the two regions, we want to use comparative language also. So the median of the Northern African countries or data is about 92%, which is higher, actually much higher, than the median of these Central African countries, which was what, 62%. So that's our center. So we made a conversation or made a comparison about the center of the data.
Kevin Smith, please come to the main office.
So, so we have our CUS and BS, so we have the center. We want to talk about any unusual features. And so we'll talk about more formal ways to discuss, unusual features. But usually the big thing that we want to talk about are potential outliers. And we'll talk about a more formal way to do that. But to me, these two are really, really far out, particularly that 34. Everything else, doesn't seem like it's really super far away. Since we haven't really talked about how to calculate outliers yet, at this point, I think what we probably want to do is just call them potential outliers. And again, that would be an unusual feature for us. So we probably say something like, what is it, the Northern African countries have potential outliers of 34% and 49%. And many values, this is like our cluster stuff, and many values in the 80s and 90s. Okay, so now we have our unusual features. We've actually already talked about the spread with kind of discussing the ranges of those values. The only last thing we really need to kind of talk about is the shape. And so Central Africa's data, again, this is, in the real world, of course, things aren't really, really pretty. You might say maybe kind of mound-shaped. If we were to put, a tablecloth over top of that, kind of mound-shaped, you might be able to make a case for, right skewed in that case. But we want to make a decision one way or the other, and usually we say things like roughly. So with the Central African countries, we can say that it's roughly mound-shaped. The CA data is roughly mound-shaped. Roughly mound-shaped and symmetric. Whereas is strongly left skewed. So that's pretty much that. The other thing we can kind of talk about, which I maybe just forgot to mention, is when we talk about skewness on this, let's see if I can actually group these guys together. I can actually sort of maybe do something like this. What do I want to do? Format, sorry. I can group those into like one thing, maybe. And if I were to rotate that whole thing, it essentially becomes a histogram. And so it's a little bit easier to see on this that this is in fact skewed left. Okay, we always want to look at it from the perspective of, you know, the horizontal axis being here. What would a histogram of that look like? So it is sort of very strongly pulled to the left in this case. Okay, one last quick thing here. So again, this is really big, important stuff. Comparing distributions, describing data, is trying to tell a story about, you know, what the data is telling us, especially with comparisons here. Make sure you're using comparative language. Make sure at the end that you just, you know, somewhere off to the corner here, maybe you just put like a cuss and BS and check it off just to make sure that you've done all the things. You know, we talked about the range here, so that's a spread. And we talked about the median, and that's our center. We talked about outliers, that's our unusual features. And we talked about the shape a little bit in that last sentence. So make sure you're doing all those things. A good response when you're comparing distributions will always talk about those four things. All right, very last quick example here is a split stem plot. Sorry, a split stem plot. And so sometimes the data is so condensed that we have to kind of pull it apart a little bit. You know, we would not want to see just four categories here. So the idea is that we just want to kind of spread this apart a little bit to maybe see some of the other features in the data. And so, you know, you can see from this data set, this is, you know, 20 high school males, how many shoes do they have, pairs of shoes do they have. We could represent that in just a regular old stem plot like this. Or we could separate it so that this stem of 0 has been subdivided. So anything that's like 0, 0 to 0, 4 would go here. Anything that's 0, 5 to 0, 9 would go here. I can split the ones. This would be 1, 0 to 1, 4. There's nothing in here that's 15 to 19 and so on and so forth. We just call that a split stem plot. And the idea of that is to simply give it a little bit more definition. When we pull it apart like this, we can actually see that there are some gaps in here, and those are kind of hidden over here. We don't really see that as much. Okay, so that's all I have for the notes. I know I say all kind of jokingly because it was kind of long. So I have these homework problems to kind of keep up with what we did. You could also work on the reading guide. Please make sure you bring your calculators with you to class tomorrow. We will be working on a calculator activity where that will be required. And I hope you guys have a good day. Thanks for listening.